Okay, so let me start with a number that should genuinely bother you. Taiwan's TSMC makes about 90% of the world's most advanced semiconductors. One company, one island, sitting roughly 100 miles off the coast of China, and the entire global economy, including America's defense infrastructure, runs on what comes from that island. Now, look, I want to be fair here. TSMC is incredible at what they do, and I'm not throwing shade at them. But the fact that America, the country that literally invented semiconductor manufacturing, has outsourced this much of its most critical technology to a single geopolitical pressure point, that took decades of bad decisions to pull off. The CHIPS Act tried to patch it. TSMC is building fabs in Arizona. Intel is spending billions of dollars trying to get back in the game. But all of those solutions are working within the same old playbook. Big fab, long timeline, 5 to 7 years from groundbreaking to a chip you can actually use. So when Elon Musk stood up on March 21st, 2026 at the old Seaholm power plant in Austin, Texas, and announced Terafab, I genuinely paid attention. Not because it's Musk, but because the actual idea he put on the table is something the chip industry has never tried before, and I think it deserves a proper breakdown. Now, let me just lay out the basics first so we can get into the details. Terafab is a planned semiconductor fabrication facility jointly being built by Tesla, SpaceX, U.S.A, and now Intel. The prototype facility is going up at the Giga Texas site in Austin, with a full-scale permanent campus planned somewhere that requires thousands of acres and hasn't been finalized yet. The total cost for the initial phase sits somewhere between $20 and $25 billion. And that's just for phase 1. The goal of the full project is to produce 1 terawatt of AI compute capacity per year, 1 trillion watts of computing power annually. To give you a sense of what that actually means, TSMC shipped about 15 million 300mm equivalent wafers in 2025, and that was their biggest year yet. The full Terafab vision, according to analysts from Bernstein Research, would require processing the equivalent of 22.4 million Rubin Ultra GPU wafers, 2.7 million Sierra CPU wafers, and 15.8 million HBM4E memory wafers every single year. And that's not the bigger version of what exists today. That's an entirely different category of manufacturing operation. The project is targeting 2 nanometer process technology. That's cutting edge. Only 3 manufacturers in the world currently produce sub 5 nanometer chips at a scale: TSMC, Samsung, and Intel. The initial output target is 100,000 wafer starts per month. Now, at this point, you might be wondering, do we really need all that? Well, Musk's companies need chips at a scale that the current semiconductor industry literally cannot supply. He wasn't shy about this at the announcement. He actually acknowledged his current suppliers and said, and I'm paraphrasing here, "We're very grateful to Samsung, TSMC, Micron, and others, but there's a maximum rate at which they're comfortable expanding. That rate is much less than what we need." Then he said that all the fabrication facilities on Earth currently produce only about 2% of what Tesla and SpaceX need across all their projects. 2%. His exact line was, "We either build the Terafab or we don't have the chips, and we need the chips, so we build the Terafab." Now, think about what Musk's ecosystem actually demands in terms of chips. Tesla's full self-driving system runs on custom AI inference chips. Optimus robots need those same edge inference chips by the hundreds of millions, and Tesla has stated publicly that they want to eventually produce millions of these robots per year. XAI is training some of the largest language models in the world. SpaceX wants orbital AI infrastructure, which requires chips that are hardened for operation in space, and none of the existing foundries were built with these specific requirements in mind, and none of them are able to scale fast enough to meet the timeline Musk is working with. So the question wasn't really, should we build this? It was, can we build this at all? And that leads into the part that I find genuinely fascinating. Now here's where things get really interesting, and this is the part that I think gets lost when people just talk about the dollar figures. Terafab is being designed as a fully vertically integrated facility, and I don't just mean the company makes the final product, I mean every single step of semiconductor manufacturing happens under one roof. Logic fabrication, memory production, advanced packaging, testing, and the big one, lithography mask manufacturing. Photomasks are the templates used to print circuit patterns onto silicon. Right now, every major chip fab in the world outsources photomask production to specialized companies, and it takes weeks to get them back. That one handoff alone adds months to a chip development cycle. Terafab brings photomask production in-house, and according to Musk, combining mask making with fabrication and testing in the same building creates what he's calling a recursive loop. Design a chip, build it, test it, revise the mask, and start again without ever shipping wafers between facilities. He says this could compress chip iteration timelines from the current 6 to 9 months down to days. Nobody in the world does this today. There's no marketing. That's a structural difference in how chips get developed. Tesla figured out this with cars. If they can figure it out with silicon, that changes a lot. The two chip categories the facility will initially produce are 1. Inference chips for Tesla vehicles and Optimus robots, essentially an evolution of the current AI4 chip, and 2. What they're calling the D3 chip, which are custom designed for orbital AI satellites. That second category is a completely new territory for the semiconductor industry. Now, on April 7th, 2026, about 2.5 weeks after the announcement, Intel formally joined the project. Intel CEO Lip Wu-Tan confirmed it, and Intel's stated role is to contribute its expertise in designing, fabricating, and packaging ultra-high-performance chips. Their exact words were that they'd help refactor silicon fab technology, which is corporate speak for we're gonna help redesign how this whole thing works from the ground up. Intel joining matters for a specific reason. TSMC operates as what's called a pure-play foundry. They fabricate other companies' designs. They don't co-design the chip. They don't do the packaging. They're just a manufacturer. Intel is different. Intel can co-design chiplets, fabricate them on advanced nodes, and package them using 3D stacking technologies. For someone like Musk, who needs custom silicon for cars, robots, satellites, and AI training simultaneously, that end-to-end capability is more useful than just handling off a design to TSMC and waiting. There's also the geopolitical angle. If Taiwan's situation gets complicated, any company relying on TSMC faces a supply cliff. Terafab, built in Austin with Intel as a manufacturing partner, is the hedge against that scenario. And honestly, I think that's a strategic calculation that makes complete sense regardless of how you feel about the rest of the project. Now look, I want to be honest with you, and I'd be doing a bad job if I didn't acknowledge the skepticism here, because there is a lot of legitimate skepticism. The full 1 terawatt vision requires somewhere between 142 and 358 fabs, according to Bernstein's estimates. A single modern 2nm fab costs between $25 and $35 billion to build. Do the math. We're talking somewhere in the neighborhood of $3 to $4 trillion for a full build-out. For reference, TSMC spent $165 billion over years to build 6 fabs in Arizona, and those fabs won't even reach 2nm production until 2029. Then there's the equipment problem. Tom's Hardware did an extensive analysis showing that building 126 logic fabs alone would require around 12,600 lithography systems. ASML, the only company that makes the most advanced EUV machines, shipped 48 EUV scanners in all of 2025. The math just doesn't work at that scale in any reasonable time frame. And the workforce problem is just as brutal. Even assuming future fabs only need 1,500 employees each, the full Terafab vision would need over 300,000 highly skilled semiconductor workers. For reference, TSMC's entire global workforce was about 83,800 people at the end of 2024. So now, the full 1 terawatt dream is not happening in 5 years. Maybe not even in 20 years. And I think Musk knows that too, honestly. Now, the grand vision of Terafab is almost certainly overambitious in its timeline. The full scope might never fully materialize. I'll grant the critics that, but the core of what they are building, a prototype fab in Austin that proves out the vertically integrated fast iteration model, that's real. That's happening right now, and that actually matters a lot. Construction at GigaTex's North Campus started by April 13th, 2026, less than 4 weeks from announcement to dirt moving on the ground. That is an extraordinary pace for any construction project, let alone one this complex. The first real product coming out, this is Tesla's AI-Fi chip, which claims 40 times performance improvement over its predecessor. Small batch production is expected in 2026, with volume production targeted for 2027. The pilot production line in Texas is planned to start at 3,000 wafers per month, scaling up from there. And honestly, even if Terafab just proves out the single building iteration loop, just that one idea, it becomes the model that the rest of the industry copies. You don't need to build 100 fabs to change how chips get developed. You just need to prove the method works. America has been talking about semiconductor independence for years. CHIPS Act, billions in subsidiaries, TSMC fabs in Arizona, all of it moving at government program speed. Terafab is something different. It's moving fast, it's private, and it's built around a genuinely new model. It's happening on American soil, with American partners, solving an American strategy vulnerability. That's worth being excited about. Even when the skepticism dialed up, this still is one of the most interesting things happening in the chip industry right now, and I'll definitely keep covering it as it develops.